In this video, we'll talk about pressure in fluids. Pressure is defined as the force per unit area. There's something I need to add to this, and that is that the force is perpendicular to the cross-sectional area. Okay? Pressure is treated as a scalar quantity even though it has a direction. The thing about pressure is that it's in all different directions. And so we tend to treat pressure as a scalar quantity instead of worrying about the direction. The units for pressure are going to be pascals in the metric system. 1 pascal is equal to a Newton per meter squared. This definition of pressure is true in any situation, not just for fluids. You can see from the equation that pressure is related to force and area. Think about what it would mean to get your feet stepped on by a sneaker or a high heel. Which would hurt more? Why? Fluids can exert a pressure normal to any contact surface. Remember, normal means perpendicular to. Pressure is the same in every direction in a fluid at a given depth. If it were not, the fluid itself would flow. A perpendicular force is applied to a certain area and produces a pressure P. If the same force is applied to half the area, the new pressure on the surface is... Go ahead and pause the video and select an answer. Okay, so let's see if you chose the correct answer. The correct answer is A. If you double the force, it would double the pressure, but if you half the volume, you end up doubling the pressure. A 50-kilogram person stands on a square board with sides of 2 meters. What is the pressure in pascals exerted on the ground by the board? Go ahead and pause the video, remembering to write out all of your work. Okay, so let's take a look at your answer. Pressure is equal to force per unit area. The force in this case is the force perpendicular to the cross-sectional area. That's going to be the person's weight. So we have mg divided by the cross-sectional area. The cross-sectional area is going to be the length times the width of the square. So that gives us 4 meters squared. Substituting into the equation, we end up with a pressure of 122.5 pascals. 4 cubes lie on a tabletop as shown below. Which 2 exert the same pressure on the table? There's 2 answers to select. Go ahead and pause the video now. Okay, so let's see which 2 have the same pressure. You should have chosen A and D. And if you look at the numbers, it kind of makes sense. The pressure at a depth of h below the surface of the fluid is due to the weight of the fluid above it. Now be very careful. This is the weight of the fluid above it. Okay, so here the pressure at some depth h below the surface of the fluid, okay, so this is at some depth h, okay, is due to, the force, which is the weight of the fluid above it. So we replace it with mg, where this m is the mass of the fluid. Now what we're going to do is we're going to multiply the top and the bottom by h. This is effectively multiplying by 1, isn't it? Okay. Notice here that the volume is equal to the cross-sectional area times h, and we can replace the v, or the ah here, with v here. Now you can see that you have the mass per unit volume right here, and that's equal to the density. So we can replace that with rho. So here, the pressure is equal to the density of the fluid times the acceleration due to gravity, the magnitude, notice there's no vector sign here, times the height of the fluid column. So here you see examples. The pressure at a given point depends on only the density of the fluid and the depth, not the shape of the container. Notice all 3 containers have a different shape, but the pressure at any given point only depends on the density of the fluid and how deep you go. So if I choose the bottom of this beaker, it's going to be the same pressure for all 3 containers. Okay, this is valid for liquids whose density does not change with depth. So if the density ends up changing with depth because you're compressing that fluid, this is going to change the results here in this in what we're saying here. There are 5 containers of the same fluid in a physics lab. Which has the greatest pressure at the bottom of the container? Okay, so let's see if you chose the correct answer. Hopefully you chose D. D is the correct answer because of the height of the column of fluid. What is the pressure in pascals at the bottom of a swimming pool whose depth is 2 meters? Make sure you write out your solution, writing the equation and substituting the numbers in. Go ahead and pause the video now. Okay, so let's take a look. We know that pressure is equal to rho GH. Substituting in our numbers, we end up with a pressure of 19,600 pascals. In the next video, we're going to talk about the difference between atmospheric pressure and gauge pressure.